Welcome to Chapter 8 in Statistical Reasoning. We are going to start with Section 1, which talks about the basics of hypothesis testing. We'll work through a problem and set one up and then solve it using technology. So if you have your calculator, whether you are using the TI-83 or if you're using an 84 or if you're using stat disk, we're going to use technology to solve these problems. So the first thing we need to talk about is the fact of an hypothesis. So in statistics, a hypothesis, I'm just getting my pen working here. A hypothesis is a claim or a statement about some type of property of a population, a group we're trying to learn about. And a hypothesis test is the procedure that we use to test this claim. So the focus that we're going to use today is this example of 1,009 consumers were asked if they were comfortable with having drones deliver their purchases. 54% or 540 of them responded with no. So we're going to work through this problem and do different parts of it. So using our P to denote the proportion of consumers not comfortable with drone deliveries, we end up that the claim is equivalent to the claim that the proportion is greater than half. So in symbols, we would say that P is greater than 0.5. We want our proportion to be more than half or the majority, and we're going with the majority is more than half. The expression P is greater than 0.5 is the symbolic form of the claim. You always want to start by figuring out what that is first. In this situation, our big picture, we have the claim that the population proportion P is such that P is greater than 0.5. Among 1,009 consumers, how much do we need to get a significantly high number who are not comfortable with drone delivery? The result of 506 is just barely more than half, so we would consider that not significantly high. 1,006 or 99.7% would be significantly high, but where would 545 fall? Is 54% significantly high enough? Well, we're going to actually run a test to find that out instead of just saying, well, we think it is or isn't. And previous to this, we would always say if it was within 2 standard deviations, or we would do significantly low was below 2 standard deviations away, and significantly high was above 2 standard deviations away, and now we're going to move to actually testing. So we are going to use technology to do this. Here's some examples of some outputs of what they would look like. We have stat disk, which is what we are using for our stuff. We have the TI-83 or 84 Plus, which you may have. We have Minitab. Minitab is a program used by a lot of professional companies. It's kind of expensive, so of course not much with a public entity can afford it. And then StatCrunch is another option. We want to see if our test of significance, if it's appropriate or not. We did start talking about this in Chapter 4, which I just alliterated to. A null hypothesis, we use the symbols H sub O, and that's the symbol we're going to use. It is a statement that the value of a population parameter And we are going to focus on proportions and means. Is equal to a claimed value. And over these next few videos you will hear me say equal to, equal to, equal to. The null is always, 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 always equal to. So I should never see you have a different symbol in the null hypothesis. The other option is the alternative hypothesis. Some books use H sub 1. Some use H sub A or H sub capital A. I'll kind of go back and forth so that in the different journals you were reading it could have had any of the above. So the idea here is that this is a statement that differs from the null. And when we're using the symbols, it depends. It could be any of the following three. It could be greater than, less than, greater than, or not equal to. So your claim could be that something is equal to, in other words, your claim would talk about the null hypothesis, or your claim could be that something is less than, something is greater than, or just that something is different than a specified number. And depending on which one you would use on how you would write your final statement. But your null will always be equal to, and your alternative will always be one of these three symbols. Now as you're getting used to this process, what is going to be beneficial is this procedure. And so you can kind of work through it, and we'll work through it here today, but you can work through this on your own when you're working on the problems. So first identify your claim. Then put it into symbolic form, then write your null and your alternative hypothesis, select your significance level, identify your test. I'm going to focus on the p-value method, though you could use the critical value method, and then you restate your decision in non-technical terms. When we're working with this, if you're using the confidence level interval method, which I will not focus on, but one thing that's good for you to get used to is how to tell what confidence level it's at based on its significance level. If it is a 0.01 significance level, then that 1%, if it's two-tailed, that 1% is in both tails, so you have a 99% confidence. If you have a one-tailed test and you're doing an alpha or a significance level of 0.01, that's in each tail. So 0.01 in the left, 0.01 in the right, you end up with 2%, so you have a 98% confidence interval. If you have 0.05 and it's two-tailed, that is in both tails, so it's a 95%. If it's one-tailed, that's in each tail, so then the 5 and the 5 makes 10%, so we're down to a 90% confidence. 10% in a two-tailed is split, so it's shared by both. So we end up with a 90% confidence interval. If it's a one-tailed test and that 10% is in the single tail, the other tail is the same amount, so I have 10 and 10 or 20, so I would be down to an 80%. Again, I'm going to focus on the p-value method, but sometimes you might need to find a confidence interval. So in the steps that were in that chart, we're going to identify the claim to be tested, we're going to give it its symbolic form, and then we're going to write our null and our alternative hypothesis. The example that was given above gave the claim that the majority of consumers are uncomfortable with drone delivery. So identify the claim to be tested and express it in symbolic form. We are going to use a P to do that. So our symbolic form we actually already wrote down. It was that P was greater than .5, going with the majority just being more than half. So that's what it was in symbolic form. And so given the symbol form, that must be true when the original claim is false. If p is greater than 5, the other option would be that p is less than or equal to 0.5. So this is the claim. This is the other option. So we know it's either going to be the claim or it's not going to be the claim. So step 3 is to write our null hypothesis and our alternative hypothesis. So we had two options. We had our claim, which was p is greater than, why is my pen not working, 0.5, and we had our other option, which was p is less than or equal to 0.5. The one that has the equal sign, that is always going to be your null. So my null is that p is going to be equal to 0.5. I will always have my null be equal to. I should always see that symbol in my null. So then I have to think, okay, what's my alternative? In this case, the claim was that p was greater than 0.5. So that is going to be my alternative. Notice that I don't care if p is less than. That was not part of the situation, so I just leave it out. So now we're going to talk about our significance level. Sometimes they'll be given to you and sometimes they won't. You'll pick your own significance level. We just are using the idea that whatever we are is the probability of rejecting the null when the null is true. So depending on how critical the situation is, the lower the alpha or the significance level. If you're dealing with anything medically, you should use a very small alpha like 0.01. If it's not very critical, you can do 0.05, which tends to be the most common one given. And if it's even less critical, you could do even a 0.10 if you wanted to. Now remember, we went over earlier how the significance levels correspond with the confidence intervals. So what you could do is think about what confidence interval you want to set, realize if it's a one-tailed or a two-tailed, and then you can go ahead and set your alpha level accordingly. So in this situation with our idea of delivering with drones, it's not very important. So let's go ahead and use a significance level of 0.05. So my alpha I'm going to use is 0.05. So step 5 is to identify the test statistic that we are going to use. We have to decide, is it normal, is it a t, is it a z? So I have this chart to help with that. So is it a proportion? So are we dealing with a part of something, which in this case we actually are dealing with a part of something. So we would do a proportion or a normal z test. We have to make sure our requirements are satisfied, which we will on the next slide. That NP is greater than or equal to 5 and NQ is greater than or equal to 5. If you were doing it by hand, you would use that formula for your test statistic. If you were doing a mean test, we would use mu, and then we would have to differentiate between a t and a z, and there is a typo on this slide. We do a t if we don't know the standard deviation for the population, and we would use a z if we do know the standard deviation for the population. It's more common to use a t because that's what happens in life, but we do have that option. So if we check our requirements, we had 1,009 and our p is 0.5 and our q is 0.5. So if we multiply 1,009 by 0.5, well, half of 1,009 is 504.5. So in both cases, we are definitely greater than or equal to 5, so that requirement is met. So now that we've decided that, we know we're going to do a one proportion z test. So you would grab whatever technology you're going to use and run that test. When you run that test, if you're using the TI-83 or 84 calculator, here are the results. So I have a test statistic of z equals 2.549 or 55, and then it also spits out my p-value. So my p-value is 0.005. When you're doing this, make sure you do not confuse your p-value with your p-hat or your parameter. The p-value is the probability this is your p-value. That is your probability of your test statistics at least as extreme as the one obtained. Your population proportion is p, and your sample proportion is p-hat. So make sure you keep those straight. Now we have to decide, are we rejecting or not rejecting? Excuse me. So what we've decided when we looked at this, we ended up with a p. Actually, let's back up real quick. Let's grab it. It's a 0.005. So I'm going to bring that forward. So my p-value is 0.005. My alpha was 0.05. So I'm going to compare these. My p-value, 0.005, is definitely less than my alpha level of 0.05. If the p-value is less than or equal to alpha level, you will reject the null. If the p-value is greater than the alpha level, we will filter reject. Since it is definitely less than, we are going to reject the null. So if the p is low, the null must go. So we must reject the null. So if we're going to reject the null, we have to restate this in terms that make sense. And there is a chart to help that. We could say there's sufficient evidence to support the claim that the majority of consumers are uncomfortable with drone deliveries. We definitely have to make sure we're careful with that. So let's look at some options. In this table, you can either keep it out of this slideshow and just print it out to help you out, or this is also in your book. So our original claim did not include the equality because it was p was greater than 0.5, so we're working with one of the two bottom ones. Sorry, did not include, so we're working with one of the two top ones, and we rejected the null. So that's why we were able to say there's sufficient evidence to support the claim that the majority of consumers are uncomfortable with drone deliveries. So that's how we chose that, is off that slide. So then you'll just make sure you pick the one accordingly. So make sure you're careful on how you say it. We should never say it in certain words. Here's some examples of things you should not say. Make sure you are careful of that. And then if you wanted to check equivalent methods, remember we could do a confidence interval method, we can do a critical value method, we could do the p-value method. I'm going to focus on the p-value method for the rest of this semester. But if you wanted to know the proportion, if it's the confidence interval method is equivalent, it is not for proportion, but it is for a mean, and we will not be doing the standard deviation testing. So hopefully that helps. I will make sure I get the slides up on Blackboard if you want to fill them in as we go, and I will also make sure you have the directions for how to run this on your calculator. Thank you and have a good day.